Alright, so we are going to have this section. Kindly visualize how people don't subscribe. Kindly subscribe and share with your friends in Obuasi, your friends in the. We are going to look at this question that we have for foundation. So a 4 meter wide steel foundation is founded with a depth of 2 meters. So the depth of the foundation is 2 meters. When we use the black particle, it's 2 meters, right? And the angle of friction for the foundation is 32 degrees. Gamma is 17.5 kilonewton. Now, for general shear, the equation for safe foundation is given by P prime E plus L N Q plus 1 over 2 gamma D N gamma. The first one, we have to find our shear, H2 by gamma D, right? So our shear, gamma is 2.5, and depth is the depth is 2.5, not 2.5. The depth is 2.5 by gamma, which is 17. So our Q is equal to 43.75 kilonewton per meter per height. Then if our phi being 32, we can use either the chart or the table. So let me bring them very shortly, then we work together. So this is the chart that we can use, right? This chart and find your LC and NC values, right? You can also have the graph. A situation when if they don't give you the chart, they will give you this graph. This graph where you just trace. So what is very important to these people is that if you are using this chart here, then you just need your angle of friction. You get it on the soil. Then you just need your NC, that is the bearing capacity factor. But if it's this chart, you just trace it. So you see that on this chart, we have this line. When you use the red, you should know how to read using this guy, right? So in the question, we have our phi to be 32, right? So if it's 32, then these are our parameters. This is my N, P, my N here, and my so I can put them here. I can put them here. My N P is 34.04. My N Q is 28.52. And my N gamma is what? N gamma is 26.87. So with this, I can now continue with my question, right? So gotten everything, I can put it in my equation. So my QU will be equal to C was given in the question 27, right? So 27, NC is what? 44.04 plus my Q, which is the geostatic stress, which is what? 43.75 plus my NQ 28.52 plus my 1 over 2 gamma in this case is what 17.5. My B, that is the width of the foundation in the question was what 4 meters. Here's it. So multiply by 4, then times my N gamma, which is 26.87. And so my Q U is going to give you what? We get 3377.28 kilonewton per meter. And that'll be the end to the first question. So the second question, let's see what is required of the black. So in the second, we have a circular footing with diameter 6 meters founded at a depth of 4 meters below. So the depth of the foundation is 4 meters, right? A circular foundation, you get by looking at the side, it's look like this. Looking at the side of the circular, it's circular. So when you look at it, you see, let's see this side, you get that is the side view, and the diameter. So the diameter of that foundation is what 6 meters, right? 6 meters. Okay. Now they give us C prime to be 20 kilonewton per meter squared. Phi prime is so 28. Gamma is 19.3 kilonewton per meter watt cube. Now here we are looking at local shear. Local shear. So local shear we use C bar, which is given by 2/3 of C prime, and we use phi bar. Phi bar is given as tan inverse of what 2/3 of tan phi. You get it? So first thing that I have to find is my C bar. So let me find my C bar. My C bar here, which is 2/3 of C, which was given in the question as well 20. So my C bar is given as well 13.33 kilonewton per meter squared. Then I have to find my phi because it's local share. The phi given to me in the question, I cannot use it to find my bearing capacity parameters. No, I need to obtain what the phi bar. So it's the phi bar that I will use. So the phi bar will be my phi bar, just as the equation suggests, is tan inverse of 2/3 of tan phi prime, which is tan or 28, and that will give me my tan phi bar. So that is equal to 19.51. But you see, in this chart, there are no decimal numbers, so we have to what? We have to convert it to whole number. So I will say that this is equivalent to 20. So if I have this to be my phi, then I can use it to find my bearing capacity parameter. So 20, I come to the chart, and this is 20. So this is 20. So these are my bearing capacity parameters. These are my bearing capacity parameters. So I'll write them down. So my NC 17.69, my NQ is 7.44, and my N gamma is what 3.64. So now I have them. I can continue. Let me draw this guy down. Okay. So with that increase, I can find my Q, which is gamma BF. So my Q gamma is what? Gamma is 19.3, BF is 4. And so my Q will be equal to my Q will be equal to 77.2 kilonewton per meter one squared. So now I have every parameter. Now I need my equation. So my equation Q ultimate bearing capacity is 1.3 C bar NC plus Q plus what 0.3 gamma Q N what gamma, right? Uh-huh. So I have these as my parameters. Now, the reason why we didn't use this phi to find for the bearing capacity factors is because the question is of local shear. And local shear we work with C bar and phi bar. So we need to find phi bar and use the phi bar to find your bearing capacity parameters. So that's what we did. So I can go on to find the ultimate bearing capacity to be what? 1.3. C bar we had it to be 13.33. NC is what 17.69 plus Q. Q we had it was 77.2. NQ is 7.44 plus I'm continuing down here plus 0.3. Gamma is what 19.3. E is the diameter. So in case they give you radius, you have to convert it to diameter. So B is what 6 diameter, then N gamma, which is 3.164. So my ultimate bearing capacity is going to give me what? I'm going to get 1006.6817 kilonewton per meter. Okay. So these are just simple questions that I'm giving so that when we get here, so these are questions without how do you call it, water table and the rest. Yes, to make it very simple and easy to understand. We get to question where we will have to calculate for when there is groundwater table and the rest. Alright. So this is another question, but this time around it is a square footing. So 3 by 3 square footing is founded at a depth of the depth of the foundation is 2 meters below ground surface, right? And the phi of the foundation of the soil is 15 degrees. Gamma of the soil is 16.5. C prime is what 30 kilonewton per meter one square, right? Now the width will be what 3 meters for the square foundation, right? All right. So with this in place, first of all, I can find my hill. Let me use the black one. I can find my Q to be equal to df for gamma, right? So my Q df is so 2 meters, gamma is so 16.5. So my Q is equal to 16.5 times, so that is 33 kilonewton meter one squared, right? Now, what is the formula? If I have look general share and it is a square foundation, so the ultimate bearing capacity is given by 1.3 C prime NC plus Q NQ plus or 0.4 gamma E and gamma. So I need bearing capacity parameters. Now my phi given to me was 50. So I go to the chart. Phi is 50. So I need a chart the phi 15. So where is 15? So this is here they made a mistake. Here is supposed to be 15, right? So this is my 15. My 15, this is my NQ. Is I'm sorry, my NC, this is my NQ, and this is my N gamma. So let me write them. It's a little bit far for you to keep out easily. What do you call it? The 15. Right? It's supposed to be 15. I think the chart, the people that prepared the chart. So it is supposed to because we cannot have 15. So this is 15. Uh-huh. So with that, this is the NC, NQ, and N gamma, right? Okay. So in that case, my NC is 12.86, my NQ is 4.45, and my N gamma is 1.52. As simple as that. So let's put it in our equation and solve for this question. So my QU is equal to 1.3. C bar and C prime is what 30. NC is 12.86 plus Q, which we had 33, and Q, which is 4.45 plus 0.4. Gamma is what? Gamma is 16.5. The width is 3, and the N gamma is 1.5. So you just put it inside and our ultimate. QU is equal to QU is equal to 7678.486 kilonewtons. Yes, as simple as that, right? Okay, now let's go to the second question where we have the water table. So I'll put this guy down. Put this guy down. Let's look at this question. Some of them I'll let you get inside. So let's look at this question. So this is the whole question that has both the water table and everything together. So water wide straight heating expanded at a depth of 3 meters below the ground surface in a soil and everything. So let's draw this question. Let's draw. We need to draw in order to understand what we are about. So let's build the excavation made is my footing. The depth of the foundation. Depth of the foundation is PF is what? 3 meters. This is my foundation. Right. Then the groundwater table is at a depth of what? 3 meters from the ground surface. So the groundwater table is also here. So the groundwater table is at the base of the foundation like this, and it is 3 meters. Right. So it's at the base of the foundation. Just as you can see. Okay, so with this schematic diagram, we are good to go. So let's look at the things that we so with this. First of all, we need to find Q, which is a D of gamma, right? Now with gamma, now Q is the static stress, that is the column of material above what the foundation. So the soil that is causing how do you call it, stress onto the foundation, the one above it. So we are going to use so above the foundation, the soil there is like we use the normal space, right? We have 4 by 17. That's the normal unit rate. It's my 12 against using against being 51 kilonewton per meter watt per. Alright. Now the next thing that I'm supposed to do is find because quick heating. So I need to know what my formula would be. So QU is what P prime NC plus what 12 N square plus 1 over 2 gamma is what gamma, right? Yes. So that is in place. Now I need the bearing capacity parameters. Now what is my phi? My phi was what? 33 degrees. So I need to go that. Then I bring it down. So I will use it down. So my task is 33. Where is 33? So I need this value. I need this value. What is that? So in that case, my MC is 38 and 0. My N4 is 32.6 and my N gamma is 1.6. N gamma is 1.6. So I can now put it here. Let's look at something. In the equation, see there is a gamma in the equation. N gamma in the equation. N gamma. Now because the water table is at the base of the foundation, our gamma will be equal to gamma prime. The gamma in the equation. So gamma prime is gamma sat minus gamma of water. And the gamma sat was 18.3. So minus gamma of water 10. So we are going to get 8.3. So that will be the gamma that we use in the equation. So now we have everything in place. So my QU, the C, the question was 25. My NC is 48.09 plus my Q is 51 and Q is 32.23 plus 1 over 2 by 48.3. That's my gamma. Then the width of the foundation. The width of the foundation was given as 4 meters. So yes, 4 meters. So the width of the foundation is 4. Then my N gamma is 31.94. And so my Q will be given as 3,880.4.94 kilo Newton per meter. Okay, so that is the opening bearing capacity. And the next question is asking us to find the net bearing capacity. So the net bearing, so flow net is given by flow ultimate minus flow static. So flow ultimate is 3880.94 minus the static 61. We are going to get flow net is equal to, sorry, this is the, I didn't calculate it. So this 3931.94. Nine three one is what 94. And so when you do the subtraction, you're going to get 3880 point what 94 kilonewton per meter. Okay, kilonewton per meter. Then the next one is to find the net allowable bearing capacity at a factor of safety of 3. So that is Q allowable net. It's given by the net ultimate bearing capacity divided by the factor of safety. And so the 3880.94 divided by a factor of safety of 3. That will give us what? 1293.65 kilonewton per meter watt squared. Then we are asked to find the load per meter by a factor of safety of 3. Load per meter, that is Q per meter. And that is equal to the Q allowable net by the width of the foundation because it's a straight foundation. So the width, so we have 1293.65 by the width, which is what 4. Is what 4. So we are going to get the Q. The load per meter is going to give us 5174.586 kilonewton per meter. And we are done with that. Let's try to this question. So this question, we're going to solve one and give the rest to you. So I'm going to solve the number. Let's see this one that I'm going to like this. So uh, let's look at this question. So I'll do this one, this guy, rectangular footing. Then you guys will go and do the second question beneath it, right? So this is a local share question. So first of all, I need to draw the foundation and parameters. So I'm doing for the second question, right? You are doing this. You're doing this. So um, let me let me use the dark one to draw. So the depth is what 4.5 meters, right? The width of this foundation is 3. It's a rectangular foundation. The width is 3 and the length is 4.5. Then C prime is 20 kilonewton per meter squared. Phi prime is 28 degrees. Gamma is 19 kilonewton per meter cube. And gamma sat is what 21 kilonewton per meter what cube. Right. Then the groundwater table is at a level 4 meters below ground surface. So from ground surface down 4 meters, that's where it is. Now the depth of the foundation is 4.5. So 4 meters will be above the foundation, right? So somewhere here, somewhere here. So this is where our water table will be. So at the depth of 4 meters. So from that side to the bottom of the foundation will be what, zero 0.5 meters, right? You get it? Okay. So with this in place, you can now solve some analysis. So first of all, we need our scale. Now, you started. So we need effective because there's water above the foundation. So you know how to find effective. So from here to here, there's no water. So that's going to be all by the gamma, the dry gamma. That will be what? 90 plus here. So that's gamma prime. So let me give you the equation. So here is going to gamma, right? Gamma df minus d plus gamma prime plus d. Versus where df is the depth. Df is the depth of foundation. D is the distance from water surface to base of foundation. So that is it. So basically, so my Q is going to be gamma, which is what 19 by what by 4 plus gamma effective. That is buoyant, right? That will be 21 minus 10 times or 0.5. And so my Q in this question is going to be my Q is going to be what 81.5 kilonewton per meter. Right now, see the question is what local share. So before I go to anything, I need to find my C bar, which is 2/3 of C prime. So 2/3 of 20, that'll give me 13.33 kilonewton per meter watt square, right? Then I also need phi bar, which is what tan inverse of what 2/3 of what tan phi. Are you okay? And that's what tan inverse of 2/3 of tan what 28, and that will give us what tan inverse. Let me see. So tan inverse of 2/3 of tan 28. So 19.5. So that's what 19.5. We approximate it to 20 degrees because our chart does not have decimal. So we go to the chart. Bring the chart here. Our 5 is what 20. So I need 20. So this 20. So I need this in that side. So with that 20, you can see my bearing capacity parameters or factors. Parameters or factors to be given by. So my S is what 17.69. My N Q is what 7.44, and my N gamma is what 3.164. I guess. Now, what type of foundation is a rectangular foundation? So, what is the equation applying the bearing? So, rectangular foundation, the equation is given as QU is equal to P bar NC multiplying 1 plus 0.3 B over L plus Q and Q plus 1 on 2 multiplying 1 on 2 gamma B and gamma multiplying 1 minus what? 0.2 B over what? L, right? So this is what I have. So I just put every parameters I have in. So let me translate 5. So I can see that my QU is equal to C bar. We had 1.3, sorry, 13.3. So 13.3 and C is what? 17.69 multiplying 1 plus what? 0.3. B is what? 3 over 4.5. That's the length given in the question. Plus Q was what? 81.5 multiplying NQ. NQ 7.44, right? Then plus 1 over 2 gamma. So this one too, the gamma that we use in this equation, let me show you. Because there is water table, the gamma that we use in this equation will be the what? Effective, right? So I will use the effective gamma, which is what? 21 minus 10, right? Multiplying n gamma, which is 3.64, multiplying 1 minus what? 0.2, multiplying b 3 over what? 4.5, that. And so my ultimate bearing capacity is going to give me what? 940.744 kilonewton per what? Meter. So I'm done with the first aspect of the question. So we're done with this. Now the net bearing capacity. Net bearing capacity is the equation is given by Q net is equal to Q ultimate minus Q, right? We had 940.744 to be the ultimate. Then the Q was 81.5. So if you do the subtraction, the rate is 859.244 kilonewton per meter of square. Are you okay? Then we were supposed to find the net allowable at a factor of 50. Okay. The fuel allowable net is going to be fuel net over a factor of 50. So my fuel net is what? 859.244 over a factor of 50 of right? And that will give you 286.4148 kilonewton per meter square. Then the last question is the load for a factor of safety of 3. You see, when we were looking at the strip foundation, the question was load per meter because for the strip, the length is very long, so we want it per meter. But here, it is a rectangular foundation, so we can easily find the area, right? So the load, in that case, will give us to find the load. So the load is equal to the Q allowable net times the area. And so the Q allowable net was 286.4148. The area of the rectangle is 4.5 by 3. And so my Q is equal to what? Is equal to 3866.1598 kilonewton. Alright. So the third question, I'll leave it to you, try it. But this should be the answer that we are supposed to get for that one. So for this one, the ultimate bearing capacity is Q is 10.176 kilonewton per meter square. The next is 576.176 kilonewton per meter square. Then your still allowable net is 858.725. Then your load per meter is going to be 2576.176. Now here is when in the equation, if you solve this very right, in the equation, your gamma that you use in the equation will be given by the formula 1 over b multiplying gamma d plus gamma prime d minus d. So that will be the gamma that's used. Alright, so let's move on to our last question. Well, we have two questions now. Do one. Now let you do and do the rest. Oh, yes, so if you are watching that video, I would advise that you subscribe to the YouTube channel, to share it among your friends, especially those in Nebraska and those on UMAT campus to have access to such the easy explanation to this. So let's see this question. So a square footing is to be founded at a depth of 2 meters. So we have a footing, a square footing, right? The depth that we are founded is footing. It's what? 2 meters, right? That's the only thing they give us. They give us the kill as the force is 300 kilonewton. That's the gross load, right? Um, the groundwater tables are to great depth below the ground surface. Means that it does not have any influence on the foundation. When you hear that, the factor of safety given was 3. So these are the only things given to us. We don't know. It's a square what footing. So we don't know the dimension of the square footing. So let me give it the B, right? All right. Now wait, K is equal to K gross times sorry K gross allowable, right? It is the same as my K gross, right? So it's a K capital K is equal to K gross times the area of what of the foundation. It's a square foundation, so the area is going to be what U squared, right? Now we are looking for the side. That's what we are looking for. So in that case, um, now what is scale gross? Scale gross is also equal to scale ultimate over factor of safety. So we can put it in this equation. You can put this here, right? So I can see that. Let me come here. I can see that K is equal to scale ultimate over factor of safety times B squared, right? Then I can see that Q times factor of safety over QU is equal to B squared. Now I have every other thing except QU, right? It's a core foundation, so you need a formula and it's general here. So QU is equal to 1.33 prime NC plus Q NC plus plus 0.4 gamma E and gamma. So I need to find my Q, which is given by df gamma, right? So my Q df is what? Df is 2 liters, gamma is 17. That's going to 34 kilonewton per meter was squared. Now I need to find my bearing capacity factor. So my phi given to me, phi given to me is what 32. So I can go and pick it up right from the table. Now when I pick it up from the table, my NC was um give me a minute to check. My NC was 44.04. My MK was 68.52. My N gamma was 26.87. Right? Now in the question give us a key time component to zero, right? It means that this whole thing will go to zero. This will also to the equation go to zero. So this is not to be needed. Right? So I can see that my QU is equal to Q, which is what 34. Q, which is 34, multiplying NQ, which is what 25.52 plus 0.4, multiplying gamma, which is 17, multiplying the B, which I don't know, multiplying N gamma, which is 26.87. So my QU will give me what? 969.68 plus what? 182 point what? 716, right? Now I can put this in this sorry, I can put this in this equation, right? So you see that Q was 300, after 53, all over Q, which is 969.60 plus 182.716 B equal to B squared. So if I put the triangle, 969.60 B squared plus 182.716 B equal to 900. So I'm going to get 182.716 B squared B cubed, right, plus 969.60 B squared plus, sorry, minus 900 equal to 0. So when I do it, I'm going to get two negatives, I'm going to get three values. B1 is negative, B2 is 0.891, and B3 is also a negative value. And we know that length cannot be negative. So we cancel the negative out and we keep this. So the length or the width of the foundation or the dimension of the foundation, so the 0.891 meter by 0.891 meter. Thank you very much for enjoying our video. So the last question, you can try your hands on it. Leave this one. Thank you very much for joining us. A lot of those who are pleasure. Bye.